Welcome to EDU-VALUED Academy, where education is evaluated. In my basic geometrical concept part 2 video, I discussed about orthocenter, incenter, circumcenter, and triad. Today I have a question. Which triangle has same orthocenter, incenter, circumcenter, and centroid? I answered that day also. It's an equilateral triangle which have the same orthocenter, incenter, circumcenter, and centroid. Today I will show how centroid divides a median in the ratio 2:1. It's a concept and conceptual idea. I will just share with you all. Already centroid, a point of concurrence of medians. And we know median is a line segment joining the vertex to the midpoint of opposite side of a triangle. I already discussed in my basic geometry part 2. If you like, you please watch that video and then proceed here. It will be easy for you to know how centroid divides a median in the ratio 2:1. Here I need a theorem that is known as midpoint theorem. Midpoint theorem, without which I cannot prove a centroid divides a median in the ratio 2:1. Let me tell you what the midpoint theorem is. A line segment joining the midpoints of the two sides of a triangle. A line segment joining the midpoints of a triangle, obviously midpoints of two sides of a triangle, is parallel to the third side and half of it by length. That is the theorem. Here we have to know DE is half of BC by length and DE parallel to BC. That's what we know about the midpoint theorem. How it is, let me explain shortly. Here, ABC is a triangle and D and E are the midpoints. And D is the line segment joining the midpoints. So I have to prove D is parallel to BC and DE is half of BC. We need a construction. We will produce D to F such that DE is equal to EF. This is the construction. We are constructing in such a way so that DE is equal to F and FC is joined. Here we have constructed DE is equal to F and FC is joined. This is the construction what we need for this theorem to be proved. Here it is already given A is equal to EC, D is equal to F, that's what the construction is, and this is obviously the vertical angle. With the help of this side angle side, these two triangles, I mean ADE triangle, ADE is congruent to triangle CFE. By simplicity, FC is equal to DA. FC is equal to DA AD by CPC. We already know AD is equal to BD. So FC is equal to BD. Again, side opposite to this angle by CPCT, side opposite to this angle CPCT. These two angles are equal. But you see, this angle DAE and ECF are alternate interior angles. So AB is parallel to FC. AB is parallel to FC. For this angle, we know alternate interior angles, and these two sides are parallel. So definitely BD is parallel to FC. Opposite side of a quadrilateral are equal and parallel. So this is a parallelogram. Thus, with the connection of this one and this one, opposite sides are equal and parallel. So DBCF is a parallel. So DBCF is a parallelogram. Now it's very clear. D is parallel to BC proved. This is proved. And opposite sides of parallelogram are equal. So DF is equal to BC. Now DF is nothing but 2D. 2D is equal to BC. So D is equal to half of BC by length. That's what the theorem is. We have proved these two. This is called midpoint theorem. A line segment joining the midpoints of the two sides of a triangle is always parallel to the third side, and by length it is half of the third side. With the help of this, we are going to prove how centroid divides the median in the ratio 2:1. Here you see the picture. ABC is a triangle. We know centroid, here G is the centroid because this is the point of concurrence of median AD, BF and C. AD, BF, CE, these are all medians passing to the point G, and G is centroid. We have to prove AG is to GD is equal to 2:1. Let's see how we can prove this one. Let's have a construction. AD is produced to H. AD is produced to H such that AG is equal to GH. Once we are producing AD to H such that the AG is equal to GH, what does it mean? It means G will be the midpoint of AH, and G is the midpoint of H. And already CE is a median, so E is the midpoint of AB. So if I consider ABH, now let me consider triangle ABH. If I consider triangle ABH, now we have to prove AG is to GD is 2:1. That's what we are going to prove. Otherwise, this is BG is to GF is also 2:1. CG is to G is also 2:1. I already told you that AG is produced to H such that if it is H such that AG is equal to GH. So G is the midpoint. Now if I consider triangle ABH, Can you see? ABH. G is the midpoint of H. E is the midpoint of AB. So definitely E and G are the midpoints of side AB and AH of ABH. By midpoint theorem, EG is parallel to BH. So once EG is parallel to BH, this implies EC, that means GC. So GC is also parallel to BH. Number 1. Similarly, in triangle AHC, in triangle AHC. AHC, again, G is the midpoint of H. F is the midpoint of AC. By midpoint theorem, GF is parallel to AC. Similarly, BG is parallel to AC. So, we have now the concept. Here, GC is parallel to BH, BG is parallel to AC. So, GBHC is a parallelogram. Therefore, GBHC is a parallelogram. Is a parallelogram. Once we have come to know GBHC is a parallelogram, so D is the midpoint of both the diagonals, GH and BC. We know diagonals of a parallelogram bisect each other. Diagonals of a parallelogram bisect each other, so D is the midpoint of GH. Therefore, so we have come to know diagonals of a parallelogram. Diagonals of a parallelogram bisect each other. Bisect each other. This implies GD is equal to DH. This implies GD is equal to DH. But AG is equal to GH. But we know AG is equal to GH and GH is equal to 2GD. So AG is equal to 2GD, AG upon GD, 2 upon 1. This is 2:1. We have got it. So this way centroid divides ambiguity in the ratio 2:1. Here is a circle. It is an equilateral triangle. ABC is an equilateral triangle. Triangle ABC is circumscribed by a circle, and also a circle is inscribed by the triangle. This one. Now, with the help of this centroid divides a median in the ratio 2:1. In the case of equilateral triangle, here median is same as the altitude. And we know how to find out the altitude of an equilateral triangle with the help of side. Can you see? Here, if I say A, this is D, so this is your AD. This AD is known to us with the help of side S given of an equilateral triangle. We know AD is nothing but √3 upon 2 into side. That's what I told you earlier in my basic geometrical classes. And you please do watch my videos of basic concepts of geometry, part 1 and part 2. It will help you boost your concept. So far as my belief is concerned. Here O is a center. This O is centroid, this is orthocenter, this is incenter, this is circumcenter. That's what I told you. Centroid, orthocenter, circumcenter, incenter, these are the same for the equilateral triangle. Now we know AD is equal to root 3 upon 2 into side. As we know how to find out, that's what I told you earlier. You please do watch. Otherwise, AD is root 3 upon 2 into side. Now we know centroid divides the median in the ratio 2:1. Here this is, even it is a median, it is also a side bisector. And side bisector, the point of side bisector, the point of concurrence of side bisectors is the circumcenter. So we can find out the radius of the circle inside the triangle. So if this is capital R for the radius of the bigger circle, so R is nothing but 2:1, that means 2/3 part of AD. 2/3 part of AD. AD is also root 3 upon 2 into side. 2 cancel. This is root 3 cut root 3. 1. This is side upon root 3. That means we have a relation. Side is equal to root 3 into R. This one. We can easily find out the radius if the side of a triangle given, or if radius is given, we can find out the side of an equilateral triangle which is inscribing the triangle, equilateral triangle. Similarly, if the triangle is inscribing this circle is inscribed by the triangle, so we can find the smaller radius of the smaller circle. This is nothing, the first one, 1 is 2:1. So R is equal to 1/3 into AD. And AD is 1/3 into root 3 upon 2 into side. Okay. So this is root 3 cancel. So side is equal to 2 root 3 R. This is a relation between the circle inscribed in the equilateral triangle and the side of an equilateral triangle. So it will help you solve mensuration problem. I do hope you are watching this video and you are clearing your concept. So if like, you subscribe my channel, press my bell to have information or notification, and share this video with your all relatives and friends. Now, this is the concept I have tried to clear about the centroid. We know centroid divides the median in the ratio 2:1. How it is so, we have proved, and I'll be happy if you have this concept. Adopt this concept to solve all critical questions related to equilateral triangle. Thank you very much.